The section I've all been waiting for, method syntax. Methods are similar to functions. They are declared with the fn keyword and their name. They can have parameters and a return value, and they contain some code that is run when they are called from somewhere else. But methods are different from functions in that they are defined within the context of a struct or an enum or a trait object, which we cover in chapters 6 and 17 respectively. And their first parameter is always self, which represents the instance of the struct the method is being called on. Defining methods. Let's change the area function that has a rectangle instance as a parameter and instead make an area method defined on the rectangle struct as shown in listing 513. So we have the struct outside of main and implement on rectangle. Are you implementing it on there? We're implementing it to. We're implementing it in rectangle. So here's the implementation block. And we have one function in the block, which is taking a reference to self, and that makes it a method. So function area takes one argument, which is a reference to self, and it's automated because down here you see where we use it. We don't actually have to put self or anything else in the hole there, and this is, we see these a lot. Well, like we've been using methods all along. Okay, so but it does take. Yeah, so it actually does take an argument. It's just that the parameter is taking itself as an argument, and it is an implementation of rectangle. So it knows this stuff already. Right, okay. So it results in U32, and that U32 is calculated by self.width times self.height. To define the function within the context of rectangle, we start an implementation block. Then we move the area function within the implementation curly brackets and change the first, and in this case the only parameter, to be self in the signature and everywhere within the body. In main, where we called the area function and passed rect1 as an argument, we can instead use method syntax to call the area method on our rectangle instance. The method syntax goes after an instance. We add a dot followed by the method name, parentheses, and any arguments. In the signature for area, we use reference to self instead of variable rectangle of type reference to a rectangle, because Rust knows the type of self is rectangle due to this method's being inside the implementation rectangle context. Because being inside the implementation block rectangle context. Note that we still need to use the ampersand before self, just as we did in reference to rectangle. Methods can take ownership of self, borrow self immutably, as we've done here, or borrow self mutably, just as they can any other parameter. We've chosen reference to self here for the same reason we used reference to rectangle in the function version. We don't want to take ownership, and we just want to read the data in the struct, not write to it. If we wanted to change the instance that we've called the method on as a part of what the method does, we would use a mutable reference to self as the first parameter. Having a method that takes ownership of the instance by using just self as the parameter is rare. This technique is usually used when the method transforms self into something else, and you want to prevent the caller from using the original instance after the transformation. The main benefit of using methods instead of functions, in addition to using method syntax and not having to repeat the type of self in every method signature, is for organization. We've put all the things we can do with an instance of a type in one implementation block rather than making future users of our code search for capabilities of Rectangle in various places in the library we provide. Where's the arrow operator? In C and C++, two different operators are used for calling methods. You use a dot if you're calling a method on the object directly, and an arrow if you're calling the method on a pointer to the object and need to dereference the pointer first. In other words, if object is a pointer, object arrow something is similar to dereference object dot something. Rust doesn't have an equivalent to the arrow operator. Instead, Rust has a feature called automatic referencing and dereferencing. Calling methods is one of the few places in Rust that has this behavior. Here's how it works. When you call a method with object.something, Rust automatically adds in a reference or the mutable reference or dereference, so object matches the signature of the method. In other words, the following are the same. p1.distance reference to p2, or reference to p1.distance reference to p2. The first one looks much cleaner. This automatic referencing behavior works because methods have a clear receiver, the type of self. Given the receiver and name of a method, Rust can figure out definitively whether the method is reading a reference to self, mutating a reference to self, or consuming self. Consuming. Taking ownership. Consuming. The fact that Rust makes borrowing implicit for method receivers is a big part of making ownership ergonomic in practice. So, does that mean that I can say that this is a reference to rect1.area? I mean, looks like it. Did I run it before? No, I didn't. See, because there's no cargo in there. Well, I guess we'll cargo run it right now. Yeah. The area, right. Okay. And then they have said, yeah, but you don't have to do that. In fact, we're teaching you not to do it. So I say, okay, I won't. And it does the same thing. Okay, now I was having some... Was it because I put new lines inside of the quotes that it... Okay, so what if I just do this? Blam. Oh, okay. What if I do this, and then that, and then do this? Yes. So it gives me... Oh, wow. So having this, the quote open, now it starts caring about whitespace. So we have the new line and then two tabs. Okay. That is probably not best, I bet. What if, I mean, can I just do like a, I wonder what the cleanest way to do this is. And by this, I mean this. Oh, it's not yellow. Okay. It's yellow here. I guess because it's an escape character, and I'm escaping the string literal. But if I'm not in the quotes, I don't have to escape the string literal. Yeah, so here we have, oh, okay. So now it does not, where are we? Yeah, before, it started caring about white space after, starts caring about white space after this, but then again, that's the only place that it'll take the new line. Signifier token. Alright, methods with more parameters. Let's practice using methods by implementing a second method on the rectangle struct. This time we want an instance of rectangle to take another instance of rectangle and return true if the second rectangle can fit completely within self. Otherwise, it should return false. That is, we want to be able to write the program shown in listing 514 once we've defined the can hold method. Huh. I'm like, huh. Like I haven't seen this before. But actually I have, because I've been watching Brooks Build's series, and he went through this. He's my hero. What do you say? He called it something like active. Not remembering, active recall. He used active recall and successfully remembered what the book said to do. I wonder if I can do that. So here, they're not showing me the, it's right down here. It's under there, I bet. There's can hold. Okay, so let's do this. I will, just to save a little bit of time, I'm going to copy and paste the new main, the new F in main, and I've told it to allow dead code. I'm going to go ahead and get rid of that now because I might need the help. Okay, so we're going to implement in rectangle a function called can hold. Okay, can hold, and it takes as a reference, yeah, so, okay, I mean, I just watched Brooks's video on this, so, I mean, I basically remember, but for me, the level I'm at, this is probably a really good exercise, even though I kind of already know. So, we're going to need a reference to self, and they called the other one other. And we'll take a reference to other, I bet. Yeah, so reference to other. And then I'm gonna get in on that good old this right here. Boom. Okay. So it was like we're gonna return a Boolean. All right. Return bool, and I lost my tab. How do I? What is that for me? Okay, so the other thing is a rectangle, right? So reference to self and other, right? Okay, so and I remember because I watched Brooks run into this. So another instance of rectangle, right? Not right here necessarily. I don't remember, but yeah, we're gonna put out bool and am I piling up a bunch of? No, I'm not. Okay, just kidding. Okay, so what do we? How do you even program? How do you do this? Well, let's look at our area function. It's taking. All right, so we got self width and self height. Do I want to say stuff like if? Okay. If. Okay. Let's try it. If let. No. Just let's say if. If self. If self dot width. Yeah. Okay. Can hold. So can hold means we want self to be bigger than other. So if self dot width is greater than other dot width, and yeah, I learned this, and self dot height, yeah, self dot height is greater than other dot height. Then what we do, like one of these. So if return true, so true. Nope. Okay, help me out. RLS. So width expected a yeah, this thing. Expected to type. What? No, okay. If expressions without else, evaluate to this. Okay. Oops, just kidding. How am I doing this wrong? Oh my goodness. Right. So, CIW. That's what they told me. Okay. Other width. We want to reference to other. Expected use a reference to U32. Found U32. So I should borrow there. Even though I'm saying that borrow is already, that other's already a borrow. Because it's not a method on borrow. Right. Okay. So method syntax tells me I don't need to do that. We just read about, but we do, because this is not a method. This is a method on self, and here we have other. Okay, so what's the deal with this thing? Expected type bool. Found. So what should I say true now? I guess I'm doing ICW instead of CIW. Let's try it again. CIW. Bool. Yeah, probably true. CIW. True. Nope, same problem. So then it's telling me I need Okay, so I mean, I guess I can keep trying, but I'm just guessing because I'm kind of back. Should I back up? Should I go research this? What if I pause the video so you don't have to watch me think about it? What if I... Wait a minute now. So this is inside my if statement. And the result, if doop let result, should I say result? Like I said, it's an if, okay, then maybe I don't need anything here. Just like, only do it if. Oh! Okay, so, oh no, okay, we still want bool here. Expected bool, found an empty hole. This function's body doesn't return. Expected bool found that, and I still don't know what to call that. That's okay. Well, okay, so we got here. So a reference to rectangle returns. So if it's true, return reference to other. Yes? No? No, a Boolean. If, okay, if true, what do I want to say? Print line true? Okay, pausing the video. Look, this is my word. I will not scroll down and look down here. I will not go look at Brooks's video. I will figure this out, but I won't make you watch me. Pausing now. Oh, I mean, I didn't even have to pause. I mean, since no time has passed. And also, the answer. Okay, so I figured it out. The problem I was running into was that if my result is a Boolean, that means I have to give it exactly two possibilities in the result. So if, and then it doesn't want to assume else, so I say if reference to self dot width is greater than reference to other dot width and height greater than height, true, and just put the word there, true, right? And then else, false. So this is all I really needed right there. Else, false. Of course, what I did was I just clicked back through here to functions, and then sort of scrolled a bit until functions with return values, and tried a few things that didn't work, and then I say of course because of course I didn't go straight to the answer. Yeah, and then I hovered over it and it kind of explained it more, and I read the manual. Okay. We know we want to define a method, so it will be within the implementation to rectangle block, implementation of rectangle block. The method name will be canHold, and it will take an immutable borrow of another rectangle as a parameter. We can tell what the type of the parameter will be by looking at the code that calls the method. rect1 canHold rect2, or reference to rect2, passes in. My phone rang and now I don't know where I am. Okay, well, I think I read this. So it passes in reference to rect2, which is an immutable borrow to rect2. An immutable borrow to rect2. An instance of rectangle. This makes sense because we only need to read rect2 rather than write, which would mean we'd need a mutable borrow. And we want main to retain ownership of rect2 so we can use it again after calling the canHold method. Yeah, okay, so something just clicked for me that I think I understood before, but I've been confused regarding the ownership rules. So, taking a mutable reference to something does not take ownership, but it does have write privileges with a W. So an immutable borrow is like a read-only borrow, and then a mutable borrow is like a borrow with it's like a super borrow. Like when you okay, so if I wanted to on my machine as a user who is not root access some Etsy file that's owned by root and I can't modify it, then that would be like a borrow. So I can, open it but I can't write to it. But then a mutable borrow doesn't make me the owner, but it gives me access to. So if I do sudo vim /ets /pacmand /mirror list or whatever. Okay, so then I can get in with write privileges, but I don't become the owner. As soon as I'm done with it, my privileges are gone as well. Wonder if I'm gonna think through this and come around to agreeing that borrow is just a really great term for this. I've been struggling with it. So moving on. This makes sense. We only need to read rect2 rather than write, which would mean we'd need a mutable. Yeah. Mutable borrow is recording, right? Yes. And do I have like? No, I haven't done this while I'm recording. Okay. Am recording, not previewing. Got it. We want, main needs to keep ownership of rect2 so that we can use it again after canHold. The return value of canHold will be Boolean, and the implementation will check whether the width and height of self are both greater than the width. Excuse me. I've been pausing so you didn't have to hear those. One got through. Both greater than the width and height of the other rectangle, respectively. So, canHold method in the impl block. Function canHold takes a reference to self and other of type reference to rectangle. So far I'm like on it. Bool returns a boolean, so that means I don't need an if statement. Self.width greater than other.width and self.height greater than other.height. I mean, did they cover this in the I know it's just like basic like logical operators or whatever, or whatever, standard. That means and, right? So, but I don't remember reading it in the book. Implementing the canHold method on rectangle that takes another rectangle and tests as a parameter. So I can do away with if, and I shall. So if I delete to 0, that's, well, let's stick with it. Okay, so I deleted to 0. Did I wipe out a bracket anywhere? I did not. So let's go get that bracket and then another one. Right. Okay, so now I'll wipe out 2 brackets with this. That means I have wiped out. Why didn't it used to fix these for me? Did I turn it off? Did I tell it to stop auto indenting? Tell me, did I? Did I? Alright, cargo run. Lovely. When we run this code with the main function in listing 514, we'll get our desired output. Methods can take multiple parameters. That doesn't look like the word parameter for some reason. I mean, no, it is. Methods can take multiple parameters that we add to the signature after self, and those parameters work just like parameters in functions. Associated functions. Another useful feature of implementation blocks is that we are allowed to define functions within implementation blocks that don't take self as a parameter. These are called associated functions because they are associated with the struct. They're still functions, not methods, because they don't have an instance of the struct to work with. You've already used string from the string from associated function. Yeah, okay. Associated functions are often used for constructors that will return a new instance of the struct. For example, we could provide an associated function that would have one dimension parameter and use that as both width and height, thus making it easier to create a square rectangle rather than having to specify the same value twice. Sold. Okay, so we implemented in rectangle f in area, f in can hold. Can I go ahead and put f in square in the same implementation block? They're about to talk about that, aren't they? I think they're going to say, yeah, you can, but you shouldn't. That's my guess. Alright, f in square. I'm going to do this with no typos. So slow. Slow enough where I don't have to go back. And size, okay. S, I-Z-E, blam, and a U. Caps lock is escape. And I'm meditating on where my 3 is. I think it is in the, okay, and so in DVP, you've got the shift layer contains the numbers, and they're not in the same place. This is Programmer's Dvorak. So the odd numbers are in your left hand, and the even numbers are in your right hand. And I think I'm on 3. Yes. So that makes this 2. Great. Caps lock. And then I haven't had no typos yet. I am doing good. Okay, now we're going to use a big R rectangle, and then that space width, yes, colon, size, comma, height, colon, size, space, escape, save. To call this associated function, we use the colon syntax with the struct name. So we'll say let's equal rectangle colon square 3 as an example. This function is namespaced by the struct. The colon syntax is used for both associated functions and namespaces created by modules. Okay. Well, let's slap some of this in main. So we got we're gonna let and square. Sure, I'll just do what they did. So let's equal. Oh, that was my first typo. Okay, a rectangle. Yes. Yeah, rectangle. Right. Sure, but we don't need all that. We just need that. And then, right. Now we will println. Well, hey, I wonder if we can, well, I'll just do this. Yeah, so I'll move you, little buddy, up here, and then just get all up in here and say, give me another one of them. And I don't know if rect1 can hold sku, but we can find out. Sku. Oh wait, no, that's got to be rect1 still. Okay, but this can be a reference to sku, and sku is a thing that exists because we will have run the make a square associated function. Right, so just to sort of recap what they said here, so you've got methods which are implemented on structs. So we have the area method, and it's a method because it has this information. It knows that a rectangle has two fields. It has a width, which is u32, and height, that is u32. It knows this stuff, and so it can use self as a parameter and as a as this variable in the function. Is it a variable? I don't know. I was calling these like parameter, like this size. I was calling this parameter variable before. But anyway, so a function has access to what a rectangle is, whereas a method has access. A method implemented on rectangles knows what a rectangle is. It knows this information from the struct. But an associated function is not a method because it doesn't necessarily know. No, it doesn't know. It doesn't know about rectangle fields, the fields in the rectangle struct, because we haven't given it self as a parameter. Yeah, because if I hover over self right here, it gives me reference to an instance of a rectangle. Yeah, okay. But here we don't know anything about rectangles. We will output one though. And so we're going to build one in here, and it's taking the input u32 size variable that's created when you run the function like this. So when you let square, oh dude, this is going to be teeny tiny. It's going to fit in everything. Well, I guess I figured it out. Can hold. Okay, so the rectangle, yeah, it can output a rectangle, but it's not a method. They're going to tell me to put this in a different impl block. Let's run this. Rect1 can hold sk. True. True enough. I believe it. Well, now wait a minute. Hold on. What if I make sku, I don't know, way big? How you feeling now, Rect1? How cocky are you? Yeah, so it looks like it works. Okie dokes. So multiple impl blocks. Each struct is allowed to have multiple impl blocks. For example, listing 515 is equivalent to the code shown in listing 516, which has each method in its own implementation block. That seems like overkill. there's no reason to separate these. there's no reason to separate. If you're thinking that looks like overkill, you might be right, because there's no reason to separate these methods into multiple implementation blocks here, but this is valid syntax. We'll see a case in which multiple implementation blocks are useful in Chapter 10, where we discuss generic types and traits. Summary. Structs let you create custom types that are meaningful for your domain. By using structs, you can keep associated pieces of data connected to each other and name each piece to make your code clear. Methods let you specify the behavior that instances of your structs have, and associated functions let you namespace functionality that is particular to your struct without having an instance available. Yeah, so it actually matters. It's associated because the result is a rectangle. But structs aren't the only way you can create custom types. Let's turn to Rust's enum feature to add another tool to your toolbox.